Hello students, welcome back. Let us resume our discussion in section 3. In section 3, we are studying functions defined by definite integral. Simple form is like this. And then switch x and y, or switch top and bottom, excuse me, you're going to get negative of the integrand. The general form goes like this. And in the general form, if you keep b is just x and a is just constant, the derivative of constant is 0, so this part will be gone. And b is just x, then b prime, that's derivative of x is 1, so that too is going to be just gone, and you're going to get f of x. So this can be considered as a general case of the other cases too. So if you can do this, then you can do everything. It's just that this one is much harder. We went through a difficult example here, the tangency problem. We have 2 more to go. Next, let's do a limit computation problem. Okay, and then I wonder what the graph looks like. So, and then, yeah, let's copy and paste this thing. And then this one should be changed into arc10. Yeah, that's my function. And then I want the behavior around x equals to 2. So let's plot this one from 1 to 3. Let's see if Mathematica can handle this in time. Well, it's still working hard, so let's go ahead with the solution. Please note that this is a 0 over 0 type limit. So L'Hopital's rule applies. Oh, Mathematica is still working. How do you know this is a 0 over 0 type limit? Well, this can be rewritten as the limit of this integral over x squared minus 4. And then if you plug in x equal to 2, the denominator is 2 squared minus 4, that goes to 0. And the integral, let's see if I plug in x equal to 2 here, 2 squared minus 2, excuse me, Mathematica produced a graph around x equal to 2, around 0.5, yeah, about half. I can eyeball kind of like that. Okay, that's the graph, and we're going to come back to that shortly. Let's come back to this limit. This is a 0 over 0 type limit. Denominator is this. The numerator is this integral. Integral is a to x squared minus x. But if I plug in x equal to 2, then we're going to get, let's see, 2 squared minus 2. Top is 2 squared minus 2, 4 minus 2, so that's 2. So we're going to end up with an integral from 2 to 2. Make sense? So the integral here in the numerator, we get integral 2 to 2, and the numerator is 0. Denominator is clearly 0. Plug in 2 here. 2 squared minus 4, that's 0. Numerator is also 0. So this is a 0 over 0 type limit. How do you handle 0 over 0 type limit? We take the derivatives. So this is going to be 2x, and then we take the derivative of this integral. That goes to the numerator, basically. All right, let's take the derivative of the numerator. This integral. Okay, arctangent of this. And then I'm plugging in x squared minus x here. X squared minus x. And then I have to multiply the derivative of the inside. 2x minus 1. Did I do this right? And then I have to plug in the bottom. So whatever that, and then I have to plug in u equals to 2, and then I have to multiply the derivative of constant. So that's just 0. So this entire part just drops out. Noting that this is a constant, experienced students will just skip this entire part. That's going to be 0 anyway. So we have the derivative. So let's copy and paste this thing down here. What we have over here is inverse tangent of x squared minus x squared minus 3 times 2x minus 1 over 2x, where x is approaching to 2. Looks like this is a kind of computation we can handle with a calculator. Let's see. Denominator is 2 times 2, so that's 4. And then numerator, let's see, plug in 2. 2 times 2 minus 1, so that's going to be multiplication by 3. Yeah, I'm multiplying by 3. And then plug in 2. 2 squared, 4 minus 2, so this is 2 squared. So 4 minus 3. So arctangent of 1. Alright, arctangent of 1. What is arctangent of 1? Arctangent of 1 is pi over 4 times 3/4, so this entire thing is 3 pi over 4. So 3 pi over 4 is 2.3 something. Three pi over, 4 times 4 is 16. So 3 pi over 16, 0.58. Okay, looks like 0.58. 0.5 is over here. Yeah, okay, I'll be bigger than that. Yeah, I believe this result. So 3 pi over 16. Okay. Let's see, what did I do in my answer key? Yeah, 3 pi over 16 is correct. And, 3 pi over 16 is not a simple number. It's a rational number. So just by eyeballing it, it was a little bit difficult to see. But 0.5 is here, and 0.58 something. Yeah, I can understand that. Let's see, what did I do in my answer key? Yeah, took the derivative, and up here is the derivative computation of the integral using the fundamental theorem and chain rule, and then plug in x equals to 2 and doing the computation. Denominator is 2 times 2, 4. And then here, 2 squared minus 2 squared, so 4 minus 3, and so on. Arctangent of 1 is pi over 4. And why is it pi over 4, by the way? If you're curious, you can draw a triangle. Let's go to graphic mode. So pi over 4, we have to have 45-degree triangle. It's 1, 1, square root of 2 triangle we are looking at. And tangent is 1 over 1. So the tangent of this angle theta, is 1. And this angle theta is 45 degrees in degree measure, or pi over 4 in radian measure. So arctangent of 1 is pi over 4. Let's get out of the graphic mode. All right, that's the full solution in a single viewing window. And if you want the graph as well, it's here.